today's overall programs are, first we'll start with hands-on practice, like whatever we studied in last session, and then we'll continue with we'll start actually like we already seen the data creation, and then today we'll discuss about spatial analysis, and later the it's very important one. Post-lunch session will be on application of GIS and architecture and urban planning. Basically, only two words are there as per schedule, architecture and planning, but it covers civil engineering aspects also. So again, today, if I can see the whole lectures, they are based on whatever we are required to do in practice. So be focused and try to do your best. Okay, so we can start with the queries if anyone has. Any query from participants, or if anyone wants to share something, like if someone tried, like I've shared the PPT and data yesterday. Okay, ma'am, please take the charge of the session. Thank you.
Thank you so much, ma'am. I welcome. Actually, I'm very happy that you have invited me on this second day also. So I just want to know that how many of the participants have tried on the data. I think you must have shared it yesterday only. So is there anyone who has tried on the data? All right. So we'll start with the session, and I just want you to please open their softwares, Quantum GIS, and I'll just share my screen now. Okay. So the first query the first task that we are going to do is on the attribute data, and we will add, we will do the ordering or ascending, descending, um, uh, um, like ascending and descending methods in attribute data. So just open your software, and first of all you have to add the Udaipur data file. It is a vector shape file, so you can go to layer, add layer, add vector layer. You just browse to your data and open this Udaipur shapefile. All right, add it here and close, and open its attribute table from here, right? I hope it's done. I just want to know how many of these participants are doing it right now, so that I can keep the pace with them. And also you can also write it in the chat box if you are done with the steps that that I'll be sharing with you. So I just want to know how many of the participants are simultaneously doing the hands-on. Done. All right. So we can go on. So the first question, or you can see it in the table, we have to identify the tehsils and their values with highest sex ratio, lowest sex ratio, and literacy rates, both highest and lowest. So the two variables are there, sex ratio and literacy, and we have to identify the minimum and maximum values from the attribute data. So you have to search for this column or this field SRT. This is the sex ratio total. So just arrange them in ascending and descending order by just clicking it over there. So first is highest sex ratio is of Jhadol Tehsil with 977 value. You can note it down. And again, if I click on this field, it is arranged in ascending order. And so the lowest sex ratio is of Girwa Tehsil with 941 value. This is the first question. Second question is about literacy rate. So you can search for LIT POP, this field. And when you arrange it in descending order, you'll get the highest literacy rate. It belongs to Girwa, 77.18. And again, it is Kotra with 26.58, the lowest percentage in literacy. So this was our first task. Easy, right? Now we'll move on to the second task, that is adding a field to the existing data. And so as you can see it on my slide, you have to use the data1 file here. So I'll just show you here. You can remove this Udaipur layer by using this button, or you can right click it and remove layer, right? Now add another vector layer, data1. You can use this small icons also here. They are the shortcuts of it. You can add a vector layer from here. Go to your data place. This is the data1 shapefile. Open it, add it, and close it. Your district map of Rajasthan will appear here. Now open the attribute table. All right. First of all, switch on the editing mode from this toggle editing mode button. Click it. Go to this icon, new field. Okay. You click it here and add field window will open. Just type the name here, division. We have to add divisions to all the districts, administrative divisions. And in type, you select the text string. Length, you can keep it to 10 only. Okay. And click OK. So you can see a division field is added. And I have provided you this map of Rajasthan. You can minimize it side by side on your screen. And you can add on the divisions manually. I'll just show you for 2 or 3 districts. Suppose for Ajmer division, it is Ajmer. You can also copy it and paste it for those districts that comes in this division. So for Ajmer, it is Ajmer, Bhilwara, Nagaur. It is on 25th number, and Tonk. You can do this on your own also. I'll not take much time on this. It was just about adding a field to it and adding some values or data to your existing attribute table. So you can do this later on also. The second step, the second task related to this was deleting a field. Okay, these are the small tasks. You can do it simultaneously. Deleting a field. What you have to delete? You have to delete the state field from this data1 file. Okay. In your data1 file, you can delete the state field. I think I have already deleted that field. You just select this delete button, delete field option from here, and select your field. That is the state field. I think I have deleted already, so it is not shown here. You can go on with it. So you just try this. You don't have to write all the divisions. If you are done with deleting the field, we can move on to the second exercise. Let me know in the chat box. Is it done? You can write it in the chat box so that we can move on to the second exercise. You can practice it using the presentation slides also. Now we'll see that I have shown you how to add latitude and longitude values automatically to a point file. So for that, you have to open the school shapefile that is being provided to you. It is also a vector file, but it is a point file. So open your data from School Raj folder. It is school Rajasthan. Open it, add it. These are the schools of Rajasthan. And what we have to do, we have to add, you can see the attribute list here. You have to add a latitude and longitude column to your present attribute table. So for that, click on the processing tab from the main menu bar. Go to toolbox. Okay, a processing toolbox layer will open. You have to go to the vector table option here, right? In the below section, in the vectors list, you can see vector table is there. Open it and click on the add XY fields to layer. Processing toolbox, vector table, and add XY fields to layers. Double click it here. Your input layer will be your school Raj, that is this point layer that you have to add coordinates to it. You can see the coordinate system, WGS 84 it is. And you just run this option. It says it is finished. So close it and you can see added fields, a new layer added fields is there. You can check the attribute table of this. And here in the XY fields, you can see the longitude and latitude information in decimal degrees for each point feature. So this should be your output. You can save your outputs in the PPT if you want. I'll just open this one. These are the steps. You can also check it from here in case you are finding it difficult to do. I have also shown you the parameter screenshot so that you can check and fill the coordinates or the parameters accordingly. One more thing that I would like to add here is once you are done with your whatever option you give, whatever output you want, suppose you have gone for adding this XY field. If you are satisfied with the output, you can save this layer permanently by going through export and save feature as. So it will be saved as a new shapefile. I hope this has been covered in previous lectures. So this is a temporary file. This symbol says that it is a scratch file or it is a temporary file. Let me know if it's done in the chat box. Please update it on the chat box if you are done. Okay, I think participants have done this. Next, we will move on to another short task, that is renaming a field. You are already having a data and you want to change some field name according to your understanding. So what we will do the renaming of this field join TP to total underscore POP. See, one more thing that you should notice here is while giving the field names, it is expected that it should be small enough. Okay, it should not be very lengthy and it should not contain spaces in it. So I have used, you can see underscore here. What you will do, you go to the processing tab, open the toolbox, again go to vector table, and here you will find a rename field option. You just double click it here. From the school Raj shapefile only, which field you want to rename, you just drop it down. It is use the data one file. Sorry, I've used the school Rajasthan file. You have to open the data one file, or if it's already open there, you can use this shapefile. So you just rename the field. Input layer is data one. Which field you want to rename? Join TP. and the new name will be total underscore POP. That represents my total population. All right. These are the inputs that you have to do. Just run this, and a renamed new layer, temporary layer, is shown in the layers panel. So you can check it from by going to the attribute table, opening the attribute table, and you can see here it is the new field name. Okay. So just follow these steps and you can easily rename your field. You can check, you can try on join SR field also by renaming it to sex underscore ratio. These are the parameters that you have to use. If it's done, you can write it in the chat box. All right, very nice. Next task is about the field calculator, and for that we will use data2 file now. Okay, so open your quantum GIS and you can remove the other layers. You can remove all these layers and open data2 file here. Okay, it is given in the data2 folder, and here you'll find it data2 shapefile. Open it, add it, close. This is the data2 file. You can check the attribute table also. It has all the divisions, and let me just okay. So once you are done with it, we have to add area for each district in square kilometer. So we will use field calculator option. What we will do, we will create a new field first. We will assign the type to decimal number. We will provide length as 10, and from the geometry options in the function list, you will select the $area option. Okay, and in the expression window, what we have to do, we have to write this expression as $area underscore 10 to the power 6. Okay, for converting the square meter results to square kilometer directly. Otherwise, what you can do is you can first calculate the area by using the $area option, and you can again go or add another field, so area in square kilometers, and by dividing the output of area by dividing it to 10 to the power 6 digits. You can check the preview and we'll do it this way. Just see. This is your data. You should on your toggle editing mode. Then you go to this open field calculator button. Click it. Field calculator window is there. See, you just check this. If it's enabled, create a new field, and the field name will be area. Output field type will be decimal number. Length is, I'll keep it to 10. This precision is the value, the number of digits that you want after the decimal. So you can change it accordingly. From the function list, you go to the geometry options, open it, and here in the second option is $area. You should double click. Any particular reason that the symbol of underscore is used? Sushma ji, underscore is used to avoid spaces in the field's name. That is the thing, and that is also like it is acceptable in the software's coding language, or you can say that way. All right. Okay. Now dollar area, and you can use this division button here, or you can also type this expression from your keyboard also. Okay. So if you have you are using a laptop, and if it is having an division sign of slash, you can type slash also. Right. 1 and 6 zeros after that. 1, 2, 3, 4, 5, 6. And you can see the preview also. It is showing the area for Ajmer. It is 4 digits and after that. So once your preview is done, you can check your expression from here. Click OK. Your area has been calculated. Okay. And this is in square kilometers. I'll open my slide here, and you can write your inputs through this. Let me know if it's done. Has anyone done this? Area calculation done. Okay, sir. Okay, so we'll move on to second calculation, which will be using this area field. So it is better that you those who are doing the hands-on should calculate the area first, because the next calculation of population density will use that area field. Here again, we will calculate population density for each district, and just what is the difference is we are using a different kind of expression here. Can you please repeat steps, Gauravji? Okay, Gauravji, I think mm, these are the steps here. You can follow them one by one easily. Or if you find any problem, you can directly ask me in which step you are finding it. Any kind of error is there, or see, most of the time what happens is, since many you cannot remember all these steps, you have to focus, or in case you don't get the results, you have to start from scratch again. Can you please repeat steps? It shows error to create file. Gauraji, can you please share your screen if it is possible, so that I can see where you're finding this difficult? Gaurav Sharma ji. For that, I think I'll stop sharing the screen. Yeah. Yeah, Gauraji, please quickly share your screen.
Yes, ma'am. Yes, ma'am.
I think you're not able to share your screen. You don't have to create a file, okay? If it says create a file, you don't have to create a file. You have to just add a field, all right? So your steps, I'll just quickly show you again.
I have to add. I have to add first field, then create calculation.
Okay, you have added a field already, is it?
Edit the field and then this मतलब dialog box come there, they may create correct as well. It's already created.
I can't hear you properly. I'll just assume that what you have done is you have first created a field, I guess.
Yes, first created field in this
And
attribute table.
yeah, and if it is showing null values, what you can do, see there are various options. How can you add? If you have already created a field, okay, you have not gone to the field calculator and you have created a field area. If it is showing null values, I hope this is your question.
Yes, ma'am. Yes.
All right. What second option you can do is open your field calculator now. You don't have to select this now. Create a new field. Or okay. So if you disable this option, automatically it shifts to update an existing field. Okay. You select your field from here. Suppose this was your field. And you can again give the same expression, area divided by 1 to the power 10, 10 to the power 6.
I did their problem here. This is the problem where actually I do not select this wala field.
Okay.
So
Okay, so you can do this way also. Okay, I hope you will be able to do it. See, I have done this. All right. So there are two methods to do that.
okay, ma'am. Thank you.
Yeah. So now we have calculated the area. Now we will go on to calculate the field population density. So some parameters have been changed. You have to create a new field, P den. See, you can see the short name that I have given to it. It clearly says P density. You have to select type as whole number integer. Length can be 3 because I don't think more than 4 digits the population density is shown. The average population density of Rajasthan is already 200 persons per square kilometer. So these are the 3 letters. Okay, so it will only cover 3 spaces. That's why I've given the length 3. Select fields and values. Give the expression as join TP divided by the area. Check your preview and click OK. We can do it this way. Open your field calculator in the editing mode. Our field name will be P, then whole number it is, length is 3. Go to fields and values now. What formula should be? Total population divided by area. Okay, and you can see the preview here, it is 3 digits. Click OK here. P density or population density for each district has been calculated. You can check the lowest population density and highest population density from ordering this field. So you quickly do this and let me know in the chat box. Before clicking OK, just check for expression that you have used or the formula, you can see that it is correct or not. One more suggestion that I would like to share here is that even if you have you're using an expression and you got your results, you should manually check your results for 2 or 3 records. Okay. Let me know if it's done. Gaurav Sharma, done. I hope other people have also done this. Population density. Okay. Population density calculation. Very good. All right. So this was about exploring the attribute data. Now we will go on into the second section, that is filters. And for that, you will need 2 layers, Indore, ATM and Udaipur. So don't open the layers simultaneously. First, you should open the Indore ATM layer. Okay. You can save your results. Open the vector layer Indore ATM. These are the ATM locations of Indore district. So from the slides, the first question is, okay, first of all, you should check the attribute data. It shows 3 fields here: ID, bank name, and deposit facility 0 or 1. 1 means they have the deposit facility, 0 means they don't have the deposit facility. Total number of banks are 37 they are. Okay. You should always check attribute data for each layer. We have to find out how many number of banks are having deposit facility. So you can use a paper first of all. We have to identify two things. First, the banks, and second, having deposit facility, that means 1. So you should always write an expression in your mind, or you can write it on a paper first. If you find it logical, then you can move on with the software. Here, what we will do, we will open the attribute table, and here, show all features. In the left bottom corner, you will find the filters. Go to field filter, then go to deposit facility. Okay, and type here 1 in this cell. Hit enter. 18 banks are there in the list which are having deposit facility. Okay, so this should be your output. You can see it on the screen also. See, go to the field filter option, go to deposit field, deposit facility 1, and enter. This should be your output. Done? Open the Indore ATM file. Go to field filter, deposit facility, and 1. Okay, so it's done. We will move on to the second query. How many HDFC banks branches are there in the data? So, first of all, you should remove the previous filter. So, you click this deposit facility option here. Okay, and select show all features. Please do it simultaneously. Show all features. So, the whole data is visible. Again, you go to this field filter option, and now we are selecting the bank. So go to bank name field and type here Hdfc. Okay, click here and enter. So the result of this query will be 6 banks of Hdfc. You can see it on this slide. And the answer is 6 banks. Let me know if you find my pace a bit fast, because I think in the spatial selection section, you will need more time. So I'm just trying to quickly finish up with these small exercises. We have identified HDFC banks. Gaurav Sharma ji has done this. Is there anybody else who has completed? Done. Okay. Okay. So Now, as you can see on my presentation slide also, and yesterday also I discussed this, we have done these two questions based on filter that is available in the attribute table option. Okay, and what output it had on the map area is that out of the total points that are there on the map, it shows those selected ones which are satisfy the filter. Okay, it does not remove other features or other point layers. There is another way to do it. What if I just want to show the selected or filtered features on my map and not those which are there on the map, or those who do not uh, satisfy the filter query? For that, you have to use, you go to this right click and this filter option. Okay, you right click your layer, go to filter, and a query builder option will appear. So in the presentation, the next two questions we will be doing by using query builder. First question is, how many Axis Bank's branches are there in the data? It is similar to the second one. Here we have identified the HDFC Bank, and here we will be identifying the Axis Bank. But the output result on map will be different. Here the query will follow bank name equals to Axis Bank. You can see this expression. So in the query builder, you select the bank name, double click it. Using double click option, you can add it to the expression window. If you don't know how many values are there in this field, you can just select this field and click all here. So all the values will be listed here. Bank name, and you use this operator equals to sign, and Axis Bank, double click it here. Check this query in your systems also, bank name equal Axis Bank. Now what we will do, we will test this expression if it is valid or not. You just click test here and it says it returns 2 rows. That means expression is valid. If there is an output, that means your expression is valid. Click OK and OK again. Now you see here, these are only those Axis Banks which satisfies your query. So in the whole list, there are only 2 Axis Banks. I hope you got the difference using query builder filter and simple attribute table filter. If you are done, let me know. I'll just open my slide here. Right click your layer. Done. Okay. For query builder, right click the spatial layer, go to filter, and a query builder window will open. There you can do this expression writing. Okay, so we will move on to the fourth question or query here. How many number of banks are not having deposit facility? Okay, so our query will follow deposit facility exclamatory equal to. This is a symbol for not equal to ka symbol. Okay, and 1. Again, please use the query builder. First remove the filter, initial filter. So go to filter again, clear, and what we will do, we will select deposit facility, double click it, and not equal to 1. Okay, or another expression that you could have used is deposit facility equals to 0. Okay, that is also another way of doing this. Test it, 19 rows results. Okay, and okay again. So these are the only 19 ATMs. You can check the attribute table also. These are the 19 banks here, 19, which are not having deposit facility. Let me know if it's done.
Is there any voice issue?
All right, sorry. I think I muted my mic. Sorry for that. Okay, I was saying, when you have a lot many records and you have to identify one record out of it, what you will do, you will go to this filter, field filter, select the field that you want to search for. Okay, so click Tehsil name, and your question is you have to identify Girva record. Type here Girva and hit enter. So it will only populate the tehsil that you want to, or the record that you want to see. Easy. Similarly, you can identify for literacy rate. How will you do this? You select the field filter, go to literate population, type 51.14, enter. It is this Gogunda Tehsil. You can check here. Similarly, you have to identify the sex ratio, whose value is 977. You can click enter, and it is this Jhadol Tehsil. See, this is the figure. So quickly do this. It is a very simple exercise using Udaipur data. You have to use the field filter option here. And in that, just type these values in associated field types. If you are done, you can write it in the chat box. Is it done? Okay, it's done. So you can practice these filters here. We'll move on to the third section, that is using query in QGIS. So far we have also used some of the queries, but they were of simple nature. Now from now onwards, we will use some advanced filter expression. For this exercise, you can again open your Indore shapefile. If it is already there in your project, it's good. Otherwise, you can add it again. This is our Indore data. What query we have? We have to identify how many SBI banks are there which are having deposit facility. And for that, we will use this AND operator. So our query will be bank name equal to State Bank of India and deposit facility equals to 1. This will result in the output. Okay. So what we will do, we will open the attribute table. You go to advanced filter option here. Okay, you don't have to use field filter now. In the second last option, it says advanced filter expression. Open it up. In the expression window, what we will use the fields first. Bank name. You can click here all unique so that you can see all the banks here. Bank name should be equal to State Bank of India. Okay, I have double click it here from the sample State Bank of India, and is the operator. So go to operators here, operators option, and you will see and. Double click it, and second field that we want is deposit facility. All unique, you can check 0 and 1 they are equals to 1. Easily, bank name equals to State Bank of India and deposit facility equals to 1. You can check the preview. If it is a number, either it is 0 or 1, that means your expression is valid. In case you have not used proper comma or spaces or symbols, then it will say, suppose I'll show you here, if I remove this semicolon, you can see my expression is invalid. So from this you have to check that your expression is right. I'll again use the column. Okay, so if it shows any sort of preview, even if it is a value or anything, that means your expression is right. Click OK here. So 5 banks will appear. 5 banks will get filtered, and from here, from these 1, 2, 3, 4, 5, you can drag your mouse cursor this way, and in blue color you can select these banks. If you minimize your attribute table, you can also see them on your map. The yellow ones highlighted are the filtered results. Easy? Please do it quickly. Just check that your answer is 5 banks. Is it done? Just check for this expression here. And you have to use advanced filter option. You just have to double click your fields to add it to the expression window. Okay. Has anyone done? Ma'am, the result from this expression will be visible in vector data. Actually, vector data is already the only data that you have. Point clear is a vector data only. So it will be shown in both the spatial data form as well as the attribute data. That can be your question. We don't have any other data. We are not using any raster data or anything. So it is your vector data only. Okay. But this visualization, this is spatial data. And when you open this attribute data, this is the attribute data. So the result will be visible in both these forms. Okay, Madhuri, if you're not clear, let me know. Okay. Has anyone done this exercise? It's quite easy. Like, you have to use more advanced filter in coming queries. So please do it quickly. So in my file, it is not visible in spatial data. Do you see this sort of result? I'll again use the advanced filter expression here, and to save my time, I'll just copy this text and paste it in my expression window. Is okay. If you select this way, okay, 5 attributes, 5 features are shown here, and you minimize this, you can see these 5 dots, yellow dots. This should be your result. It is not visible. Why? Can anyone share their screen? I'll stop sharing my screen. Can anyone share? Gaurav or anyone who are having problems? Please share your screen quickly. Okay, ma'am, now it is visible after selection. Yeah, right. You have to select it first. Okay, I'll again share my screen now. If you do not select this or the features from here, there is an option C, deselect all. This way, it will not be shown. If you select them, then only you can see your features. All right. So now we will move on to the second query, that is find out either Canada or Hdfc banks having deposit facility. Now there is a complex condition. Okay. So our expression should be bank name equals to Canada and deposit facility 1. This is first part of our expression. That's why I have used these brackets here. Okay. Then you use or, because the question is either Canada or Hdfc, but both should be having deposit facility. So this time I won't demonstrate it here. You should do it by your own. Open your query builder option now. Okay, you don't have to go to the expression window. You can do it from here, filter, or whatever way you want. You can go to advanced filter or expression also, and from here you select your fields as per this equation. You quickly do it and let me know who does it first. Your answer should be 4 banks, 2 of HDFC and 2 of Canada. If you can do that, that means you have done the task correctly. Has anyone done this? Very good. Madhuri has done this already. Okay, so for those who are not able to do this, bank name equals to your Canada. Operator that we'll be using is AND. Deposit facility equals to 1. Okay, you can type the brackets here. Now we will use another operator, that is OR. Or use the brackets again. Type the bank name first. Bank name equals to Hdfc. Use the AND operator here, and deposit facility equals to 0. This should be your expression. And click OK. See, one more thing that I would like to mention here. On the top, this bar, where it is written that features, total features are 37. Out of them, 6 are filtered here. I think I've used this wrong query because my features are 6. Let me do it again. Okay. Here I have used. You can check your query from this bottom bar also. Deposit facility, I have to type 1. Then my result will be 4. So it says total features were 37. You have filtered 4 using this query, but none of it is selected. It says selection is 0. When I select them, it says selected 4. If you select only Canara Bank, okay, then it will say selected 2. From this, you can check the selection and you can see it on your map also. These are some additional tips. So we will move on to another query. From this, we will be doing just 1 or 2 because time is already moving fast. You have to use the Udaipur data for this. So quickly open your Udaipur data, or if it is already there, we will go on with this. This is your Udaipur data. Open the attribute table and see. Find out the tehsils with literacy rate less than 60. Okay. So your expression will be literacy rate less than 60. Please correct for this query expression. It should not be less than equal to. So you go to again advanced filter. Field selected should be literacy population, and you can use the less than sign from the operators. Here you will find this less than sign. Otherwise, what you can do, you can use your keyboard also to type the less than sign. Less than 60. Hit OK. 5 tehsils will appear. You can also check this data. See this one. These are all below 60, less than 60. So you can quickly do this. The question is, find out the tehsils with literacy rate less than 60, and your result on map will be like this. 5 tehsils here are selected. Please do this. Done. Okay, very good. So you can move on to the second. You can identify the sex ratio above 960. Your query will be this one. It is similar. So you need not to perform this. You can do it on your own also later on. These are some of the queries that are using the AND operator. Okay. So 2 sections of questions will be here. Sex ratio above 960. Then you use this AND operator and add literacy rate less than equal to 30. So these tasks you can do it on your own. All the participants, I request you to perform these on your own, and if in case you find it difficult, you can always write it to me on my mail ID I have provided in the presentation. Since time is coming short, I would like to move on to the spatial selection section. Okay. So for that, you need another set of data. Okay. So here you go to spatial selection. First of all, quickly open the Rajasthan Tehsil data from the folder Spatial Selection. Okay, add vector layer, go to your data, Spatial Selection folder is there. Okay, from that, since there are many vector files here, you have to select just this Rajasthan underscore Tehsil shapefile. Open it, add it, and close it. This is the Tehsil map of Rajasthan. You can always find all these maps. They are available by Survey of India also. And there is one website, Diva GIS, these maps are freely available, but there are lot many topological errors. For that, you have to correct it. Even nowadays, OpenStreetMap also provides free shapefiles. All the layers that you see on OpenStreetMap or Google Earth engine, okay? Google Earth is also using OpenStreetMaps. So all the road layers and railway networks, rivers, polygons, they are all there, administrative divisions, they are all there on the OpenStreetMap. These are the tehsils of Rajasthan. 244 tehsils are there. You have to change your cursor value from this icon. You can see I is written here. That means the information. Now see, the cursor shape has changed. Please click on any of the tehsils. This way it will be selected and you can see all the features, attributes related to this record. Okay, it is a Nagaur district, Nagaur tehsil, and ID is there. Similarly, you can identify this Jaisalmer tehsil. This is known as spatial selection using cursor. Okay. Then what you will do is we will go to the spatial relationship selections. These are interesting ones. The first question is find out the road segments in Rajasthan where road cross over the river. So from the question, you should understand what sort of data we will need. We will need a road layer, we will need a river layer, and just to see it on the background, you can use Rajasthan district map or tehsil map or the just Rajasthan boundary, state boundary also. So we will need 3 layers, okay? Please open your data accordingly. First of all, the Rajasthan boundary, road and river Raj. These 3 layers, 3 shapefiles you have to add to your software. Okay, drag the Rajasthan file to the bottom so that you can see your line features above it. If you are not able to see because of the color, you can change the symbology. How will you change the symbology? Suppose you have to change the symbology for Rajasthan. Right click it here, go to properties. In the fill section, you can change this color. I'll give it a light tone so that you can see it in the background. Similarly, for roads, you can change the symbology to a red color. Okay, it is yellow. Just use this small triangle here. Quickly select red color, apply it, and hit OK. This is the road network. For river, you can change the symbology to blue color first. Select a blue tone, click apply and OK. So now you can see rivers and roads are clearly visible. Our question is, we have to identify what road segments are crossing a river in this data. Once you are done with the symbology, you should click here. See, 4 options are there. These yellow, you can see it here. Okay. Select by location. Okay. Just a minute, you can enable the panels that you want. So You select this by location. A select by location window will open. Here, what input we will do, we will give this road crossing river. Road cross intersect. You can disable the intersect one, and road cross river. Run it. It is done. And the yellow lines are the selected roads that are crossing any river feature in the given data. Okay, you can check it. So how many features will be selected? 233 features will be selected. Just quickly do this in case you find any problem. Just share it.
Excuse me, ma'am, your
Madam,
mic
you
is
need to unmute.
Okay,
Ma'am.
okay, okay. Sorry. I was saying that in case you don't see these options in your software, what I have done is I have added them as shortcuts to my software because they are most of the options that I'm using. In case you don't find them on your toolbar, what you can do is you go to this view option, project, edit and view. You go to the view option, go to toolbars and just check if this selection toolbar is enabled. If it is not enabled, you won't be seeing those selection options here that I am doing. So go to view, toolbars and select this selection toolbar. Now you can see these options here. Please check if you are able to do this exercise and let me know. I have used this road cross river. Is it done? Let me know.
Excuse me, madam. Where do I find out this this selection by location? I just missed it, but
Okay.
I cannot be able to find again.
Okay. Just go to this view panel and toolbars option. Here you have to see that this selection toolbar option is checked. Selection by location is not available. That's why I'm saying just check it, that go to view toolbars and enable this selection toolbar option first of all.
But madam, in selection toolbar, there is no option in selection by location. Can I share my screen?
Yeah, I'll just unshare my screen first. Okay, please share your screen.
You said na selection by.
Okay. Okay, let me just check. Which version of Quantum you are using?
3.1.
3.18.
3.14.
Okay, you can also check it. I'll just share my screen. If you all find it easy, please, Gauruji, can you stop sharing your screen so that I can share? Okay. There is another option. Can you see my screen? Okay. You go to vector, you go to research tools, and here select by location. Are you able to find it, Gauruji?
Yeah, ma'am. Got it.
Okay. Okay, so you can use this from here. My quantum version is 3.16, so probably that's why it is showing the shortcut from that toolbar. This is what is the main thing. As the versions changes, they also change some sort of interface options in the software. So nothing to worry about. You can always Google it and you'll find your solutions. Go to vector, research tools, and select by location. Now you can go do this. I'll just share my presentation. Yeah. River, road, cross, river. Please uncheck the intersect option that is by default already selected. And let me know if you are able to do this time. Done. Is it? Okay. So Gauruji is able to do it. I hope others can also do this. We will move on to the second selection, spatial selection query. We have to find out tehsils that are having schools. So now we will need two layers. First is Rajasthan Tehsil map and second one will be our school layer. So what we will do, you can switch off these layers from here. Okay, you no need to remove them. You can add another layers and we will need a Tehsil layer and school layer. Okay, you can open it, add it to your software, see. And just drag this Tehsil layer below the school layers. If you want to change the symbology, you can do it later on also. But for me, if the colors are appropriate, then you can go on. Now what we will do, we again go to select location and we have to identify schools are within Rajasthan Tehsil. You can check it from the presentation also. Sorry. The query should go by Rajasthan Tehsil contain school. This should be your query. We'll be using the contain option here, and your resultant output will look like this: 208 features. How will we will perform this? Rajasthan Tehsil contain school. Run it, close it. Done. Okay. Then we'll see this third query. We will find out the tourist places that are within Jaipur district. So for this, we will use the within option. But one complexity here is that we have the district map of whole state, as I have shown you yesterday also. First, we will filter out Jaipur out of all districts, and then we will use this within query to identify the tourist places that are associated with Jaipur only. So in your software, you can use this option deselect features, so that it will deselect the features from previous query. We will need a tourist place option layer and a district map also. So for this, you open the Rajasthan district and tourist place shapefiles. You can switch off other layers that are not required, and this way. So this is a background district map, and these are the tourist places of Rajasthan. First of all, we have to filter this Jaipur district. So for this, right click the Rajasthan district layer, open the filter. Query builder will open. Here the name to are the names of the districts. So the expression will go as name to equals to, you can check all the values. Here you can see district layers, district names. Select Jaipur here. So the name is Jaipur. See, only Jaipur district is highlighted. Now we have to select the tourist places that are within this Jaipur district. Again, go to select by location. Tourist places are within this district layer. Okay, run this, close it, and see these tourist places are highlighted. If you check the tourist place attribute table, okay, you will see these are the tourist places that are in blue color. These are the tourist places which are highlighted. You can check them here also. You can check their names also from the attribute table. So just follow this and see 6 features are selected or not. First of all, you have to use the query builder option, extract Jaipur district out of it or filter, and then use this select by location option. Is it done? Done. Okay, Madhuri has done this. So can we move on to the last exercise? we are going to finish this by completing this last exercise. Sorry, one more exercise is there. It is finding out the river channels that are not flowing through Udaipur district. Okay. So here we will use the disjoint option. Again, what you have to do, you have to extract the Udaipur district out of all the Rajasthan districts. And then we will use river disjoint Udaipur district. So our query will follow river disjoint Rajasthan district. So you can do it on your own also. First of all, you have to remove the previous filter from the district layer. You can click clear here. It is done. Select name again equals to, here we will select the Udaipur district. See, Udaipur district is selected. You can switch off the tourist place layer and you can open the river layer and you can put it above it. Okay. And now we will use the selection option, river disjoint Udaipur district, या Rajasthan district. Run this option. Close it. And in the background, if you want, you can open the Rajasthan map so that these yellow features of rivers are the rivers that are not flowing through this Udaipur district. So for that, I have opened the background image. You can see this from this slide. And if you are done, let me know. Done. Okay. So we have done all this and let's move on to the last query. We have to find out the schools in Rajasthan that could be affected by flood. Okay. Now we don't have the flood information, but what we have a river channel feature or data. Suppose if we are assuming that the flood zone will be extended about 3 kilometers from the river bank or river channel. What we will do, we need to create a buffer zone of 3 kilometers around this river. Okay, first of all, we will do this. So a new buffer layer will be created and then we will search for school locations. So there are two steps involved. First, we will create a buffer. How are we going to do this? Just remove previous filters from the district map. And here I will need only a river layer and Rajasthan district map. This way. Even if you want, you can just use the Rajasthan boundary map. So you go to vector. See, we are doing this processing on vector data. So all the vector options you will find in the vector tab. Go to vector, go to geometry to geoprocessing tools and go to buffer. The first option is buffer. Vector, geoprocessing tools and buffer. You click this. It will ask the input layer on which you want a buffer zone. So we will select the river. At what distance from the vector layer? We need a 3 kilometers distance. So type 3 here and specify the unit as kilometers. Keep the rest of the inputs or parameters as default. Just run this. See? You can see thickness has been increased and a new buffered layer, temporary layer has been created. I'll just put this river layer above it and zoom it in. So the blue color represents the river and at 3 kilometer distance, it is the buffer zone. That means in case of flood, the width of the river will increase this way. This is just a hypothetical situation. And now we will need a school layer. So schools are there. Just check it on. Go to select by location again. Here, select features from school that are within the buffered zone. See the expression, school are within buffer. You just run it. And you will see the schools are selected in yellow color, which will get affected in case of flood, this hypothetical flood situation, right? So this was another query. You can do it from this slide and let me know if you are able to do it. Madhuri has done it. Very nice. Very good. So I think these were just the sample data, and you can explore them. You can practice them always. You can explore new queries. You can always add new logics to your, or you can create your questions and you can perform expressions and see the results, what it is giving. This way you can learn many much about queries and special query, attribute query. Done. Gauravji has also done it. Very nice. So this was all from my side. In case anybody is having a question, they can ask me. I know the hands-on session are very difficult to do in online mode, but still, ma'am, participants have done this. It's a great achievement for them. So I congratulate everyone who has done this. Over to you, ma'am.
Thank you so much, Urmi ma'am, for the great and very good learning experience during this hands-on practice session. I truly appreciate your efforts and your time, valuable time, for this your presentation and your involvement in the session. I think the participants must be now more. They must be comfortable and like more confident to deal with this software, even better than before. And I expect, in fact, I would like to insist all the participants to practice more on this software and come up with their queries. Actually, Urmi ma'am will be tomorrow also. You will be with us, so you can ask your queries tomorrow also. So I would like to thanks once again. Thank you very much, ma'am.
Thank you,
And
ma'am.
I think any queries, still I can we can hear from participants.
Good evening, Joris. Good morning, Joris sir.
Good morning, Urmi. So how was your experience?
Yeah, it is good, sir. Many participants are able to do it with me, and they have really done it great.
Because the tasks which were assigned to you were too many. Good.
It was a
Yes, madam,
great
please.
learning.
So I am pleased to welcome Dr. Chore once again. So thank you very much, sir, for valuable time and joining us today.
So, ma'am, can I leave the session now?
Yes, ma'am. Thank you very much.
Okay, thank you so much, ma'am, for inviting me. Thank you.
Thank you. Over to you, sir.
Okay. So good morning, friends. I'm back again to talk to you about. Today there might be slight echo in my voice. I don't know because I'm attending this particular meeting from my college lecture hall. So that is why some kind of slight echo might be there, so please bear with that. So today we are just going to talk about the spatial analysis. So in the earlier session, or I think day before yesterday, yesterday, you have seen how to query with the data. So whatever the attribute data we enter, based on that we can query. We can just filter the things, and so many different type of options are available. So simple queries, complex queries, conditional queries, we can just execute, and using that we can just derive on certain conclusions, or we can view or visualize our data based on the attributes. Okay, so that is one part, and this particular facility is always available with the database applications, because database applications are databases. They provide us the facility to query the data. So based on certain conditions, we can query the data, and based on the query, the results are obtained. Suppose you are having a huge database of students, and you are interested in finding the boys who have scored more than 70%. So then you will query, you write a query that where the percentage is more than this, and the gender is equal to male or M or whatever is written inside the database. Accordingly, you have to use a keyword for that. So that way we can just out of 10,000 records or millions of records, in a very short time, the database will filter out the things and present a filtered table in front of you. So this way, the same kind of thing is available in GIS also. So in any GIS software, these kind of basic querying operations are always available. But another difference, big difference here is that in uh, GIS applications, we are not only dealing with the attributes. You have seen we are putting the points, lines, and polygons. Sometimes I may be interested that how many points are in the vicinity of one particular road. Say, for example, somebody is interested in starting petrol pump on a highway. So what they will do first? They will try to locate the existing petrol pumps along that highway, and depending on that basis they will perform some analysis, and on that basis they will decide that at what location the new petrol pump is needed. So here, just the name of the petrol pump will not be sufficient. The physical location, that is the geographical location of that petrol pump, is very important. So how to do it? So this kind of analysis cannot be done using a regular database query. So for this, we have to go for spatial analysis. So because GIS software deals with the spatial data, so we can perform query based on the locations, the vicinity of the features, intersection of the feature, and so many other things. So this is a powerful part of GIS. So today we will be talking about spatial analysis. Okay, so just wait for a moment. I am sharing my screen with you, and we'll see the things through a PowerPoint presentation. And I would like to demonstrate some of the things. And tomorrow we will have a hands-on session on the spatial analysis. So we will provide you some data for this. And using that data, you will perform some basic and common spatial functionalities or spatial operations, I should say. Okay. Okay, so it is not a spatial analysis. It is not a specialty. You see the spelling. It is spatial, spatial. So spatial means pertaining to space, pertaining to location, geographic location. So in this particular analysis, we will be considering the location. We will not only consider the location, we will also consider the geometry of the features. So it is really an interesting field. Okay, so what is a spatial analysis? So spatial analysis, if you define, uh, is a process by which we run raw data into useful information. So you perform some certain operations on the data. And here, what kind of data we have in GIS? We have got data in shapefile. In shapefile, we have got two types of data. One is the spatial data, that is the vectors, point lines, and polygons. Another is the attribute data, which is associated with this. So how to do the query with the attribute data that you have seen in the previous lecture? Now we will be doing the analysis and query based on the geometries or the features, that is point, line, and polygon. Okay, and on that basis we will derive certain information. Okay, the process of examining the locations, attributes, and relationship of features in spatial data through overlay and other analytical technique in order to address a question or gain useful knowledge. So what we'll do, suppose you have got a layer of contours and a layer of say soil types or geology. So then we can always establish a relationship between the things. You can have a layer of the property values and the municipal wards, so that on that basis you can establish a relationship between the property values and the real estate properties and this thing. So like that, different type of data can be taken, and the relationship between that can be understood by performing some kind of analysis. So spatial analysis extracts or creates new information from the spatial data. So whenever you will take 2 or 3 layers and will perform some kind of spatial analysis on that, as a result of it, a new layer will be created. Okay, so that layer will have the desired information. The ultimate, the end result will be in the form of a layer. Okay, so spatial analysis is a set of techniques for analyzing spatial data. The result of spatial analysis are dependent on the location of the object being analyzed. That is why we are calling it spatial analysis, because location is playing a role in this. Software that implement a spatial analysis technique require access to both the location of objects and their attributes. So it is not like that we will be considering only the geometries, only the features. We will have that there will be a role of attributes also in the spatial analysis. So it will be based on both the things. Okay. If we talk about the very first case of spatial analysis, then the name of John Snow comes. So John Snow, he was basically a doctor or a medical profession, and there was a cholera outbreak in Soho town of London in 1854. And at that time, people used to think that the cholera is caused by foul air. You know, we are talking about the time of 1854. Okay, so this fellow, what he did, he just took the map of the city and started to plot the location of the infected people or the patients on the map of city map. Then, as he plotted the things, he came to know that the infected people are using a water source from one particular hand pump. So he concluded that whosoever is using the water of this particular hand pump, they are getting infected. So what he did, he just got the handle of that hand pump removed. You can see still, this is a recent photograph. If somebody goes to Soho, they can still see this hand pump there. And so people could not use the water from this particular hand pump. As a result, the spread of the disease was stopped. It was controlled. So this is the first case of using the map to do some kind of analysis and to reach onto certain conclusion. Of course, that time this term GIS was not there. So that is why this is the first case of the spatial analysis. Later on, if you Google, you will find during the different pandemic, people just demarcated the containment zones on the maps and try to put the location of the infected people, infected wards and colonies onto the map, so that they have an idea that how the disease is spreading in their urban areas and their towns and like that. Okay, so if we talk about GIS, so what we do in GIS? So there are 4 basic broad operations here, or the processes we perform. First is the data collection. We already talked about the data collection. That is why we talked about the digitization of the maps. It is a very, very important process. We cannot do without digitization. Digitization is needed in maybe an automated way or in a manual way or whatever it is. So to create the data, you have to pick up the coordinates of the features either from the ground or from a pre-existing map or from satellite imagery. So that is the process of digitization basically. So digitization and input from existing shape files. Suppose already some government department is having the shape files, so we can take that and we can input some tabular data, the attribute data. Yesterday we attached some socio-economic data with the polygons of in the TASI. So this kind of, even a photograph may be there, even a video may be there, text may be there, paragraph may be there, web link may be there. So the attribute data may be of varied nature. So first part is to collect all this data and create a database or a shapefile for the instance. Then how to store it, how to edit it, how to delete the things, how to modify the things, how to take the things from one computer to another computer. This is our database management. So, of course, in shapefiles, we don't have enough database management facilities, but basic editing and copying and those kind of things are available there. So, second part is the management. And if you put the things in the database, then you can manage them in a better way. How you can do it in a better way? If you are putting the things in a database, then in that case you will be able to access the data from the different remote locations. That is not the case with the shapefile. Suppose the shapefile is residing on my laptop, and if you want to use the shapefile which are sitting or which are stored on my laptop, you will have to connect to me through some kind of a TeamViewer or any desk kind of an application. Only then you will be able to use it. But if I'm putting the data on a server and give the access to the right people or few people who have the rights to access the data, then they can access that data at any time from anywhere, irrespective of they are not dependent on that connection. They are not dependent that whenever my laptop will be on, only then they will be able to access it. So this is also part of database management. So if you put the data in a database, then you can keep the data on some server, and the people from the sitting in the different office premises or in different cities or in the different countries, they can access the data. Okay, so that is the second part. Third part is manipulate and analyze. The manipulation and analysis is very, very important. Just by merely creating the data, we cannot achieve anything. Okay, that will be just like tracing a map on paper, or creating a digital drawing. So the real GIS will start after creating the data. So what we'll do is we'll play with the data. We'll do some kind of manipulation with the data. So spatial processing systems will be there, and database management systems will be there. Okay. So if we okay, so this is all this the spatial processing and database management system, they all together give us facility to do spatial analysis. Because I think you are not many of you may not be well versed with the databases, so I will not be talking about the databases, but the databases will give us a very powerful facility to query the data, not only on the basis of the attribute, but also on the basis of the location. So nowadays, the spatially enabled databases are available. Using that, we can create a buffer along a line. We can find the intersection of lines, and so many other special operations we can do. So you don't need a GIS software. You just need a database and a spatial data stored on that. And by writing certain queries, we can perform all this. So when you work the things in conjugation, if you have got a powerful system like QGIS or ArcGIS, you can perform spatial analysis. And if at the same time you are putting something on a database, so by combining both the things, you can do wonderful things. in a very less time. Okay, so whatever we do is this particular part, and then as a result you get the maps or you get the tables. So whatever data you will create, you will perform some analysis on that, and as a result you will get maps or tables or both. Mostly when you talk about a table or a layer, it is basically a collection of features and the attributes. So the map and this thing will always be associated with this. Okay. So now, uh, so am I audible? Because some noise is there in the background. Is it disturbing you? Please give me the feedback.
So you're audible, sir.
Okay, thank you. So, so when we talk about spatial analysis, say there may be various options available. So, of course, there will be an input layer. On that input layer, we will perform some operation. What is that operation? We'll talk about it later. And then, as a result of that operation, our output or a new layer will be created. Okay. So, say diagrammatically, it is shown here. We have got one input layer. This may be a point layer, line layer, polygon layer, whatever it is. Then you do some operation on that layer. As a result of that operation, uh, another layer is created. On that layer, again, you perform some another spatial operation, and then a second layer will be generated. On that second layer, you perform some another third operation. As a result, final layer is generated. So like that, depending on our need, we may have 1, 2, 3, 4, 5, 6 operations on a single layer. Okay, so one layer will give, then as a result, second layer will come. On that second layer, we'll just do something, third layer will be generated. Like that, we can do the operations in a series. Okay, that is one way. Other way, we can have one layer, and on the single layer, we can perform different operations. So you will get different layers. So one layer to second layer to third layer, fourth layer, like that, you can go in a series. Or you can have one layer, and on that one layer you can perform three different altogether different operations. So that naturally the results will be different. Okay. Then it is also possible that we may have two layers, and we do something on two layers in such a way that this function will have some data from the first layer, will have some data from the second layer, and then do something on it and create another layer. So two layers can also create another layer. So we may do the operation in various combinations of these. So there is no thumb rule. It all depends on the understanding of the person who is doing this. Because whenever we'll go for spatial analysis, we will have some objective in mind, in our mind. We will have some purpose, and that purpose will be decided by the domain expert, the person who is doing it, who knows his field. Suppose somebody from town and country planning is there, and they are having the municipal ward information with them. Then based on that, they may perform certain kind of spatial analysis, that they may be interested in the houses which are east facing, and they have got area more than this, and they are close to one particular road, and then they have paid their dues, or whatever you call them, the annual charges. So all these things cannot be achieved in a one go, or in a one single operation. The different operations can be combined together, and the results can be obtained. Suppose a geologist is working with the spatial data, then he may be interested in finding out the location suitable for RT recharge of the groundwater, or the exploitation of the groundwater. So he will consider geology, he will consider slope, he will consider drainage, and like that, the related parameters and layers he will take, and will perform some operation on those layers, and ultimately he will come up with a final layer, and that final layer will have the results for that particular analysis. Okay, so when we do spatial analysis, it usually involves manipulation or calculation of coordinates and attribute variables with the various operators. So what we do selection, we do classification, reclassification, dissolving, buffering, overlay, and cartographic modeling. Modeling is a complex process, because we 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 take so many layers and establish the relationship between them, and we define the mathematical relation between the various parameters. And once we manipulate some of the parameters, the result is affected that way. So those kind of modeling is also possible. But I think to begin with, we can just talk about the selection, reclassification, dissolving, buffering, or overlay. These are the very common operations whenever we create GIS data. We very often need these kind of operators or tools. Okay, so we'll just see them one by one. Okay, so spatial selection. Spatial selection is like selection. Selection means out of the huge data, you will select something. That is as simple as that. Okay, so selection means spatial selection means based on the location. Like you selected in the filtering where the area is greater than this. So if you have got certain 10 polygons in your data, and if you write a query that filter that area is greater than this, then only those rows fulfilling that condition, they will be returned. So this kind of a filter or query is an attribute thing. But now suppose I'm having a map here, and I'm having one polygon selected, and I'm interested how many polygons are adjacent to this. So this kind of a thing I can do. Okay, so adjacency, connectivity, containment, overlay, these kind of operations may be there. So let us see how we can do the spatial selection. So identifying features based on spatial criteria. These criteria may be adjacency. If the two polygons are touching, suppose just by seeing this particular map, I can say that this 1, 2, 3, 4, 5, 6, 7, 8 polygons are touching to this particular polygon. But how the software will know? Visually, we can just see it and can tell it. But knowing this answer or getting this answer from a software will need spatial systems. Okay, so this is adjacency, connecting, containment, overlay, these kind of operations we can do. So selection based on spatial and attribute concept. Okay, say for example, this is a part of United States map of United States, and this Arkansas state is selected here, and I may have a query that I want all those states which are entirely north of Arkansas. Now you see here in this particular case, we will not consider the attributes. We will not be writing anywhere in the database that these are the states which are in north of the Arkansas. Then what about east or west or south? So all that information you cannot write, and you don't have to write, because on map it is clearly evident, it is visible. So like a human being can see and can interpret, but to interpret this through a software, you will have to have some algorithm. So these kind of things are built in into the software. So it will just get the location of each polygon, and then we'll try to draw the line to the center of each polygon, and they'll try to find the geographical directions, and based on that, it will decide that these things are into the particular direction. Then the state larger than 84,000 kilometer, not a problem, because in attribute data you are having the area of the polygons, and using that you will be able to quickly do it. And now you are combining it in the third. It states both entirely north of Arkansas and larger than 84,000 kilometers. So this kind of complex operations can be performed. So this query is based on the attribute as well as on the location. Okay. Now, I may be interested in finding the adjacent polygons. Adjacency, I can inquire. So I select one feature on the map, and then I try to find out that suppose I'm having a district map of Madhya Pradesh, and I click on any of the district, and I inquire the system that how many districts are touching to this particular district. You may wonder that why we need it, but when we automate the things, then many a times it is this kind of thing is needed, because human intervention will not be needed. If you want to see it and just interpret, that's okay. But if you want to have a list of those polygons which are touching one particular district, and then you want to do some kind of analysis based on that data, then just by seeing will not serve the purpose. Okay, so you have to have the result in some I mean in geographical format or some kind of some kind of a layer. Okay, say for example, if you talk about adjacency. So this is Arizona state, and I inquire to the system that how many polygons are adjacent to it. So what the common logic says, whenever a common boundary will be there, then the adjacency will be there. So that's why you are having 1, 2, 3, and 4 polygons. But you see, Colorado is also adjacent to Arizona. But sometimes the system may not return it. But here it is returning because this particular algorithm is trying to see the common edge. So there is a common edge, here there is a common edge, here there is a common edge, here there is a common edge, but here there is no common edge. So either we can do it by identifying the common edges between the polygons, or we can do it by finding the common nodes. These corners are known as the nodes. Okay, so there's a common node, there's a common node, there's a common node. So many common nodes are here. So that is why it will find it. But as far as Colorado is concerned, it will find only single common node, and then it will say Colorado is adjacent to Arizona. So in spatial analysis, again, because it is a lot of computational geometry is involved in it. So what kind of algorithms has been used that will affect the result. So suppose one software, one tool of QGIS will give you this kind of result, another tool will give you this kind of result, then you should not be frustrated, and you should not think that oh this is a free stuff and the two different tools are giving two different results. Of course, there may be a bug, no doubt, but before concluding, we will have to read the documentation of that particular piece of software, that what kind of methodology is adopting it. So they may explain it in simple English that this is the criteria using which they are doing it. If that is useful for us, we will use it, or we'll use another tool. And if the tool which is not available for us for our work, what we'll do? Say whenever we are at home and and alone, and we don't know how to cook, what we do? We just order the food from the market. Okay. So similarly, what you'll do, you will ask somebody to develop that particular thing to you, or if you know how to cook, you will cook yourself. That's it. So if you have some operation which is not available or is not the way you want it, what you will do? You will do it yourself. You write a code for that. Those facilities are available in every GIS software. Or if you don't have that capability, then you will hire the services. Like you hire a maid, or you just order a food from a hotel or something like that. Okay, so that's it. Now, reclassification. Suppose you've got so many polygons in your data, and just seeing those polygons will not make any sense. So what we do, based on attribute, we try to classify them. Okay, so based on the area, there may be small size, mid size, and large size polygons. So we can do some spatial analysis, and based on that, we can color them. So we can categorize them in 3 categories. So the area which is less than or equal to this particular thing, it is small. Between this and this, it is medium. It is greater than this, it is large. Okay, this is also a kind of a reclassification. So basically, in reclassification, we just group the things, okay, based on certain attribute or property. So classification is done in various ways. The geographers are expert of this particular thing. So we can have an equal interval classification. So whatever the attribute or property on which you are trying to classify the data, you will find the minimum and maximum of that data. Suppose we want to classify the district polygons on per capita income. So from the entire data set, you will find the minimum value and the maximum value, and then you will classify them as a regular interval class, and then the system will work for you and will fill the polygon depending on the each class. So if 3 classes are there, then the class interval will be large. If 5 classes are there, the class interval will be small. So you can very quickly do this kind of thing in QGIS or any other GIS. Okay, this is another very interesting operation. So whatever we have talked so far is was related to the attribute. And the attribute was playing some role in that. Okay, the geometry was not directly playing any role in the things which we have talked so far. But now we can do some play with the geometry also. So a function whose primary purpose is to combine like features within a data layer. Like features means based on their attribute, of course. So adjacent polygons may have identical values, dissolves, remove, or dissolves away the common boundaries used prior. Okay, that's fine. Say, for example, see this. It's a very interesting thing. We have applied some kind of a classification. Say maybe based on attribute, we got three types of polygons: white colored polygons, gray colored polygons, and black colored polygons. So see this, all the adjacent polygons, they all are having gray color. So seeing this map is a bit cumbersome. It is not conveying the thing very clearly. But if I remove the boundaries between the adjacent polygons, which are having the similar kind of a attribute or similar kind of a property, then it will definitely make a big polygon. So based on that some attribute, I can dissolve the property, dissolve the boundaries. As a result, I will have this kind of map. Now you see, it is more clear. Seeing the right hand side map is making the things very clearly that the black colored polygons, whatever property they are representing, are the minimum in the data set, and they are distributed throughout the area. And white colored portions are more in area and throughout distributed. So seeing this left hand side map and right hand side map, you'll immediately come to know what is the benefit of that. Okay, so this is how the dissolve operation can be used. So whenever we classify the data, we can do the dissolve operation to dissolve the boundaries between the adjacent common classes. Okay, there's one more interesting thing we can do with dissolve. So yesterday when we created the data, what we did that we just created the polygons. Depalpur, Saver, Indore, and Mahu polygons we created. But I didn't tell you how to. I mean, there may be a need where you just want the district map of Indore. You don't want to show the tehsil boundaries. So in that case, what you will do? You will redigitize probably everything, or you will have all the polygons and remove these parts and then join these things. I mean, lot of manual work will be required to do it. Or if you altogether afresh digitize a new boundary, then there will be a problem. Your Depalpur outer boundary may not precisely match with the outer boundary of Indore in this particular section, because you have to digitize exactly in the same manner. If your points go this way and that way, then the shapes will be different. Okay, if you will compute the areas will be different. So we will not do this. That is why I've not told you to create a district layer from our scanned map. But we can do it through dissolve. Say, if you remember, our attribute table is having the ID, and the tehsil names are there, and district name is also there. So because each polygon is belonging to Indore district, or we can give some number, a district ID or some common value column we can add, and in that we can write A 111112222200, whatever we write, or our name SKC everywhere, and then use this particular table of the tehsil polygons to create a district polygon. So we can dissolve these boundaries based on certain common attribute. So common attribute is Indore. Or I gave another example that you put some value like AAA or 111100. Using that particular field also you can dissolve, like how it was dissolved here. Because all these polygons are having the same gray color, means they are having one common attribute. So using that common attribute, the dissolve operation will just remove the internal boundaries, and it will retain only the outer boundary. Okay. So this same thing we'll use it here on our data so that we will have a distinct boundary like this. Okay, so this dissolve operation will work, and within no time you will very accurately create an outer boundary. There is something wonderful. Okay. After this, the next operation is the buffering. So buffer is a kind of a zone or area you create around certain point, a line or a polygon. Okay. So this is just a raster buffer. Means on the image we have created distance to the water point. So these are the water points, and as you are moving away from the water point, you are seeing that the color is becoming darker and darker. So where the areas which are close to the water point, they are appearing in white color, and as the distance is increasing, the color is becoming darker and darker. Okay, so we can always compute it from a vector data, and out of that we can create a raster map by filling the shades on it. Okay, so if you create a buffer, say for example, this is the input feature, say maybe a pond or a district, this dark colored thing you see. Okay, then if you want to create a buffer, what you'll do, you will select that particular feature, and then you will tell the system to create a buffer. But once you want to create a buffer, you have to specify at what is the buffer distance, at what should be the length of the buffer or the distance of the buffer. So once you specify that buffer, it will compute another polygon by drawing the perpendicular. So there may be multiple methods of doing it. So we are not bothered at what exactly the software is doing it, but it will create a buffer of that particular distance around this particular polygon. So the result of buffering will always be a polygon, whether you create a buffer around a point. So when you create a buffer around a point, it will be a circle. If you create a buffer along a line, it will be an elongated polygon. If you create a buffer along a polygon, it will be a polygon, but the shape of the polygon will be slightly generalized. You can see here, not many bands are there and sharp corners are there, but in the buffer they are not appearing because they will be generalized as you move away from it. If you create a buffer using this particular thing, you will have more generalized buffer. Okay, polygon. So in buffering operations, we may have the input as a point layer. We can do it on point layer. We can do it on line layer. We can do it on polygon. So once you create a buffer on points, you will have the polygons, circular polygons. If it is done on the lines, you will have again elongated polygons. And on polygons, again, you have the polygons, and the shape of the output buffer will be almost same as that of the original polygon. Okay. Now even we can dissolve the buffers also. Okay, because you create a buffer like this, one circle, second circle, three, four circles will be created, but the internal boundaries of these four circles can again be dissolved, or their numbers can be computed, and you can have the smaller circles based on the number of intersections, because here four circles are intersecting, so a smaller circle has been formed here. So nested buffers and simple buffers and compound buffers, all those kind of things we can do, but it all depends what you need, what you want to do. So the tools are available. What kind of result they will give, that is known. Now, when to apply it, whether to apply it or not, that is up to the user. As an expert, when you will play with your data, you will have the different options with you. You will have a basic understanding of those things with you. And then depending on the problem which you are trying to solve with the maps and the data, you will apply appropriate methods. So there is no thumb rule as such. Okay. Now, we can even create buffers along the rivers. Say flood zone mapping, when we create a buffer. Okay. So then in that buffer, how many villages are coming? Say when we construct big dams, we create a buffer area which will go submerged under water after the erection of the dam. So that kind of analysis can be done. Of course, the contours will also play a role into that. But suppose you are considering the things in 2D only. So we can create buffers, and we can even create variable distance buffer. So what I told you, you will select a feature, and on that you will create a buffer of certain distance. But there are certain instances where we need to create the buffers of different distances on different features. Suppose on AB road, you want to, on a major highway, you want to create a buffer of larger distance. On a state highway, definitely you would like to go for a buffer of lower distance, and another village road or something, you may need a smaller buffer. So in that case, what you will do? You will just select one particular category of road, say national highway, you'll select and then create buffer. Then you will select state highway, then you'll create buffer. Like that, you will go on. So if you got 5 types of roads, the 5 different operations you have to perform. But we can do it in a different way also. Within the attribute table itself or the database itself, we can create a column along each road. In front of each road, we can create a column of the buffer distance. So whatever the buffer distance is there in as an attribute value in that table, the software will pick up that value, and based on that, it will create buffer. Say, for example, in your attribute value, attribute table, you are having a buffer distance column, and there you are specifying that Mississippi is 100, Missouri 50, Arkansas 50, Ohio 75, and Tennessee 75. So while creating the buffer along Mississippi stream, it will use this distance. For Ohio, it will use this distance. So like that, so 50 kilometer, 100 kilometer, and 75 kilometer buffer has been created. So all these operations are functionality is available. Okay. After buffer, the next thing comes is the overlay. Overlay means you are putting one layer, another layer on top of one layer. Okay, that is it. So combination of different data layers, that is stacking of layers. Both spatial and attribute data is combined. So whenever you stack it, it is stacking means you will say, okay, sir, when we open the layers in QGIS, they are stacked. One layer is below, another is on top of that, but they are just existing. The overlay means you will do some kind of operation between the two layers and create a third layer. So that will be the result of that overlay operation. So overlay is just not visually we are putting it. Once we say overlay means we are performing some kind of operation between the two layers, and as a result of that, a new layer is being completed. Okay. So both spatial and attribute data is combined, requires that data layers use a common coordinate system. Of course, EPSD 4326, and one is at some other coordinate, they will not match, they will not overlay. So they should follow the same, they should belong to the same area, and the coordinate should also be the same. Okay. Suppose you have got one polygon of Indore and another polygon of Bhopal. Both are having an EPSD 4326. You can't overlay because they don't belong to the same piece of land. Okay. So the coordinate should be the same and they should belong to the same area. A new data layer is created. Any type of vector may be overlain with any other type. Say, you need not to bother whether you will overlay a polygon with a polygon, line with a polygon, or point with a point. Anything can be overlaid with anything. Okay. Output typically takes the lowest dimension of the inputs. Suppose you are overlaying a point on polygon, so the lowest dimension is point. Suppose you are overlaying line on polygon, the lowest dimension is line. So resulting layer will be line. Okay, let us see it. Okay, this is just an example that you are having layer A, which is having these kind of polygons, and layer B is having certain lines. So when we overlay them, you will come up with a line layer which will have both the things on it. Okay, we can just try it later on so that you will have a good understanding of it. Similarly, not only the features will be added, but their attributes will also be combined. You see an attribute table for this particular wells, ID and owner, well owner is there, and the counties are there. Okay, when you overlay, you get a layer like this. Okay, now what is happening? You see ID 1 is county is black and owner is Dickinson, because you see this particular ID is coming from here, this polygon is coming from here. So in this particular layer, both the attributes have been joined together. They have been added together. That is something wonderful. We'll see how to use it for our work. Okay, so this is vector overlay, and we can do the raster overlay also. Raster overlay means you have got the some satellite image, band 1 data, band 2 data, band 3 data, and they are belonging to the same area, the different band data. We can combine them and can generate FCC. We can do some arithmetic on that. We can do band ratioing. We can do band addition, subtraction, multiplication, whatnot. So in image processing, mostly we do the raster overlay operation. So in raster overlay, what will happen? Suppose you've got two layers. So raster data is always an array of pixels. Okay. So suppose my scene is 3 pixel by 3 pixel, which is a very short thing. Say maybe 3000 pixel by 3000 pixel. 3000 pixels in X direction, 3000 pixels in Y direction. So when I want to do the operation, what I will do, I will pick up the first pixel of the first scene and first pixel of the second scene. Okay, you can imagine it like a graph. So I am using this pixel value and using this pixel value, doing some mathematics on that and writing this onto the new image. So as a result, a new image will be created that will have the property based on the input layer 1 and input layer 2. So like that, it will do. I will do this operation for all the pixels in the image, starting from the left top and going like this and coming to the right bottom. So 3000 by 3000 pixel image, a new image will be computed. So whenever we do the overlay operation in vector, what will happen? The number of features will increase. So layer 1 is having 2 features. Layer 2 is having 2 features. Of course, these 2 features are different. But when we combine it, when we overlay, what will happen? You see, there will be 4 features. In attribute table, you are saving 2 rows. Here you are seeing 2 rows. But here you will see 4 rows. So what is happening now is see this first ID, ID1, and the cost is 0 because ID1 the cost is class is 0, and cost is 10. So like that it will match the things, and wherever the overlap is not available, it will not give us anything. So this way we can just create new data. And whenever we just overlay the things, so if you overlay a point on line, the output layer will be point, the lowest dimension. Point on polygon will be point because point is the lower dimension. Line on line, it will be line. Line on polygon will be line. Polygon on polygon will be polygon. Okay. So overlay is a general thing. You just take 2 layers and overlay them. What kind of things? What kind of mathematics between 2 layers? So these overlaying operations involve combining spatial and attribute data from 2 or more spatial data layers. In other words, we are stacking the data and looking for where the layers overlap. So we may perform operation like clip, intersect, union, subtract, or difference. Okay. So let us see one by one. It is very interesting. So when you say perform a clipping operation, so clipping is a cookie cutter kind of an approach or an operation. Bounding polygon defines the clipped single layer. Neither of the bounding polygons attributes nor geographical spatial data are included in the. Okay, just let me explain. Don't worry. You got one layer like this. Okay, and then you want to. And so one layer is having these 2 polygons and another layer is a circle, just this circle. Okay. So you imagine 2 layers, one this layer, another circle here. Okay. Now, just a minute. So I'll try to draw. So you can think of a circle like this here. So there are 2 layers. Okay. This is my first layer and this is my second layer. Of course, this location of circle is here, somewhere here. Okay, it is somewhere here. If I overlay, then it is somewhere here. So what will happen? It will just extract the things which is there inside, as shown in this particular diagram here. So you will, when you perform this clipping operation, the part of polygon which is falling inside this circle, that will be clipped, that will be chopped off. A new polygon will be created, and this one also be created like this. So you will have only the part of the polygon which is inside this circle, and it's not necessary that the clipping polygon will be a circle. It may be any irregular shape. It may be rectangular or any irregular shape. So I can put one polygon, and on top of that another polygon I can have a point layer. On top of that I can put another polygon. So the points which are falling inside that polygon, they will be taken out and they will be added to a new layer. So whenever I will perform a clipping operation, the clipped layer, the features from the clipped layer will be picked up and added to a new layer. But their attributes will not come, only the geometries will come. Okay, suppose you are having 10 attribute columns, those 10 attribute columns will not come. Okay, see, this is another example. I have got one layer, which is a yellow color thing, which has got 1, 2, 3 polygons. Actually, there are more. Okay, 4 polygons are there, and you have got a one big polygon, green colored polygon. Okay, some kind of ID is there and type is there. So if I just perform the clipping operation, means at the bottom I am putting the yellow color layer. On top of that I am putting the green layer. Means input layer is the yellow color layer and clipping layer is the green color layer. Okay, so once I perform the operation, whatever is falling inside this green colored polygon, that part, this polygon is totally inside it, it is being returned. This is totally inside it, it is being returned. This is partially inside it, so only that part is being returned. So what I will get? 1, 2, and 3. The geometry of the third polygon will be modified. It will be like this. So it will just return me these features and their IDs. That's it. This attribute value from this particular will not be added or will not come here. Okay. So this is the clipping operation. Suppose I am interested in finding the roads passing through one particular district. So on a road map of India or a road map of Madhya Pradesh, I can put that district polygon. Once I put it, all the roads passing through that polygon, they will be clipped. Means they will be chopped off. The road which is passing through that polygon may be a continuously digitized road, but it will be clipped from there. Only that part will be taken and that part will be added to a new layer. Your original data will not be affected. That will remain safe. Okay. Now, after clipping, another operation is the intersect. In intersect, we combine the two layers. In clipping, we are extracting. It is a cookie cutter kind of a thing. We are taking the data from some layer which is falling inside the clipped layer, clipping layer. Okay, that part we are taking out. But when we do the intersect, we combine the two layers. Okay. So bonding polygon also defines the, okay, this just, so here also what will happen, suppose you will perform the clipping intersect operation between these two layers, then whatever is falling outside this green colored polygon, that will be discarded. Whatever is coming inside, only that part will be taken. But the output will not be like this. You will see. Okay. So graphically, the output is the same. But if you see the attribute table, the attribute of the two tables have been added together. So if you click on the attribute table, you will find that the attribute information has been added to it. This is something wonderful. Suppose, okay, suppose you have got you have created a district map of Indore. Okay, now I give you a village list of the Indore district, and that village list is having, say for example, the latitude, longitude of each village and the name of the village. There is no information that it belongs to which particular tehsil, and some 10,000 villages are there, for example. Now, if I ask you to write the name of tehsil in each with each village name, what you'll do? What you'll do first, that Excel file with latitude, longitude, and village name, you will import it in QGIS by comma separated value file, and out of that you will create a shape file. So you will have all the dots falling in Indore district in different at different places. But you are interested in assigning the tehsil name to each village. So what you'll do? You will just see the map of each tehsil, identify each point, and write the attribute manually. That is one way. Or what you'll do, you'll select one tehsil first, or you select all the tehsils and the point data, and you perform intersection operation. So once you perform intersection operation, the tehsil names will be added in front of each village name. So that way automatically we can do this. So this intersection can be used to assign or associate the attribute between the two layers. This is something very powerful and very interesting. Then union. So it includes all data from both the bounding and the data layers. So everything will come. New polygons are formed by the combination of the coordinate data from each other. Let us see. I'm purposely putting the same diagrams so that we have a good understanding of it. So now what is happening? In intersect, we are having only the things from the input layer. Yellow color layer is the input layer, green color is the clip layer or intersecting layer, overlaying layer. Okay. Now, if you perform the union between these two, now you see how many polygons are there? 1, 2, 3, 4, and 5 were there, but now 1, 2, 3, 4, 5, and 6 polygons are there. The number 2 more polygons are added here because of this operation, and as a result, new attributes have been added. And wherever the new polygons are coming, the attribute of that is not coming. For this, nothing is there. For this, nothing is there. That's why the type is not there. Okay, because this is falling outside this green color polygon. That's why this is not having the type. This part is also not having the type. But the ID is there because this was belonging to this, and for fourth is not there. Fourth will be there. Okay, so like that we can just. Now we can perform the difference also. So suppose you got one polygon, you say P1 minus P2, what will be left? This much will be left. If you do P2 minus P1, then only this much will be left. So this difference operation can be performed even. And you might still wonder that what you will do with this kind of a thing. But when you work with the actual data, there may be instances that you may require, you may feel the need of this kind of a thing. Okay. You see here, this map is showing the areas of brick kilns around Indore, and you can see this dotted area was in 2000, and the green color area is in 2016. Okay, so from Google, these areas were mapped. So now we are seeing a trend that this area nowadays no activity is going on because there's no overlap. But this area, the activity was going on in 2000 and is still in 2016. But this area emerged only in the year 2016. Before that, this area was under some other land use. Okay, so this I can just see it and interpret it like this. But if I perform some special, so because here I have not done anything, I have created one layer of 2000, another layer of 2016, assigned them the different symbology and just putting them, not doing anything. Okay, but let us see now. Now I have performed some kind of a operation on that. So on that basis, I can identify the new areas, the old areas, new areas, the areas which are abandoned, no activities going on there, and the area which are still performing the same process, same land use is there. So this kind of thing we can achieve by doing the difference and union and things like that. See, these abandoned areas have been extracted. So like that, this part has been. So what I'm doing, I'm just subtracting the two layers. Nothing so great. Okay, areas of no change also. So these are the things which we can do. It is just a simple example, and depending on your expertise, depending on your research problem, depending on the nature of work you do in your organization, you can think of utilizing these things for your work. Okay, so this is all about, in brief, about the um, spatial analysis. So we can have some questions. So please ask the questions.
Sir, good afternoon, sir. This is Meena Kumari.
Yeah.
Sir, in the case of raster overlay, I saw that in case of vector overlay, we have the same IDs to be there for both layers, right now, sir. So it will take with respect to the IDs of uh, different layers. But in case of raster overlay, when you show the example, one layer had some other ID and the other layer had some other IDs. So there is no need for the ID names or numbers to be the same in case of a raster overlay, sir.
No, even in vector overlay, there's no need of putting the same IDs, because how it can be like that? Because one layer may be contour, another layer may be the land use, for example. So
Okay.
the IDs will never match. Because the person who will create a contour layer will give the IDs by his own understanding of the things. Okay.
Okay.
So
Okay.
it is never required that the attribute should match. And if we talk
Okay.
about the raster data, in raster data, it's a pixel-based value. So every pixel has got certain digital value, some number is there. So there is
Okay. Okay.
nothing like ID or something there, because you
Okay.
cannot
So
visualize.
depending on the RGB values, it will overlay as such.
Yes, yes, exactly. That process is totally different. Yeah. Say
Okay.
when you overlay the two vector layers, you perform
Okay.
some kind of computational geometry,
Okay.
and then based on that you manipulate the attributes and create a new data. But once you do it in a
Okay.
raster, you just do a pixel based operation, the pixel overlying the same scene in the, say, the x1 y1 of the scene 1 and x1 y1 of the scene 2. The pixel from
Okay.
that is taken up, then we move to the x2 y1, then second scene x2 y1. Like that, we move around from the scene and pick up the pixels, same pixels. We do something on that, and we
Okay.
create a third pixel. A new value is computed, and that new value is returned to the new image file. So as a result, you get a new image. So there
Okay.
is nothing like attribute. Whatever you are having is the pixel value. Of course, that will represent some attribute, of course, but there
Okay.
will not exist a attribute table, something like that.
Okay. 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 Thank you, sir.
Any other query? Thank you, sir. Thank you very much for a very interesting and insightful session on spatial
So,
analysis. As
madam, I think what I will do is just I will quickly show them some of the
okay,
things which I just uh, talked about, so that they will have a feel of it, what exactly how it is going on. So I won't take much time.
okay, sir.
Uh, I think our session is up to one, no?
Yes, sir.
Okay. So I will just quickly show what. Not this. Yeah, that is it. So if we this was the thing which we took. Okay. So now how to do it? That I will just show you. So you got this P3 layer, this one with a smaller 4 polygons, and another one is this one green colored layer. If you see the attribute of it, say four IDs are there. Okay, and this one is having only one type 400. So how to do it? We can go to the vector and geoprocessing tool, and we can perform first the clipping operation. So my input layer is polygon 3, which is a small 4 polygons, and then I want to clip it using a green colored polygon 1 and say run and close. Now see what has come. This part has come. If you see the attribute table, only the IDs are coming from the original data. Now, if I perform the same operation on the 2 layers, but instead of buffer clipping, I do intersection. So my input layer is polygon 3, and overlay layer is the polygon 1, that is green colored one, and I run it and say close. I get intersection. The result of the clipping and intersection is same on the map. But if you see the attribute table, you will find that attributes of both the layers have been added together. So this information we can use for, just a minute. Vector, this. Okay, I'll show you that dissolved operation. Okay, so that will be a good thing. Vector, this thing, Tehsil poly, yeah, Tehsil poly shape, and add and close into layer. Oh no, it's not there. Okay, I think I'll close it and reopen. I will go to the vector layer. Go to D, Indore, and Indore data. This is NP data, Indore, and I will go for Tehsil.shape and close. Okay, so I have got 4 polygons. If you see the attribute table, you have got Tehsil ID, Tehsil names, and IDs. But that common field is not there. So I will call it district, and I will put it whole number. Okay, and district ID, I can, for Indore, I decide to give one ID 1, or even I can take a field district name and I can write Indore also. So just to save time, I typed 1111 here, and I save it. So this is a field which is common. Okay, so now what we can do, we can go to the vector operation, geoprocessing, and we can go for dissolve operation here. So once I dissolve it, input layer is tehsil, and it is asking using which field I have to dissolve. So I have to use the district field, okay, and say run, close. You see, a new polygon has been created, the internal boundaries have been removed, and it has just picked up one polygon. It is actually extending it. Okay, so now we know that there is no meaning of this there, Palpur and this thing. So we'll just delete it and we'll use it. So this is how it will be done. So this is a buffering operation, and probably I will just demonstrate. Okay, I think we'll be doing the spatial analysis in the next class. So we'll see it there, not a problem. So this is how you can, so this in the vector menu, you have got the various options for the things. And you can try them because I have not covered everything, but buffer, clip, difference, dissolve, intersection, symmetrical difference is also very interesting. That also you can see. Okay, a symmetrical difference I will show you because I have not talked about it. Overlay. This guy. Yeah, okay. So suppose I have got these two layers and I want to perform the symmetrical difference. So I take polygon 2, polygon 2, and polygon 1 and say run, close. Now see what has happened. It has returned me 3 polygons. First is this one. Oh, sorry. First this one, second, and third. So it has combined, but it is returning me the things in a different way. So simple difference, symmetrical difference, all these things can give you the different type of data. So whenever you perform a spatial operation, a new layer is created. When you create buffer, new layer is created. You create clipping, you perform clipping, a new layer is created. You perform intersection, new layer is created. This is how it is. So I hope the things are quite clear to you. So any questions? Okay, then if no questions are there, then I stop here.
Okay, so thank you, sir, very much. Thank you very much, sir, for experience and your experience sharing through various sessions in this program. In fact, you, sir, added some more knowledge to this session only. Sir, I will say that as we all can see that the true power of GIS lies in a spatial analysis. It is this ability which makes visualization, we can say, or the interpretation of data very interesting and very easy. And as we will go further in the course, it will become more clear. Or I expect, sir, that your experience sharing continues like this in other sessions also. Thank you very much.
Okay. Thank you, everyone. Thank you.
So should I end the session?
Yes, madam. Yes.
Okay. Thank you, everyone. We'll meet again at sharp 2 o'clock. Thanks a lot.